Alright, so we've learned about the unit circle. Now we're going to learn about the graphs of sine and cosine, and we'll look at tangent, but we're not going to focus too much on tangent because you won't be tested on it on the EOC. So graphs of these functions are called periodic functions. One basic property is that they are considered periodic, which means a function that repeats a pattern of y values. Okay, it's doing a pattern of y values at regular intervals where one cycle equals one period. Okay, so you can kind of see the pictures down here and what we're going to be talking about, these being periodic or not. The period of a periodic function is the horizontal length of one cycle. Make sure you get all that copied down. So we're going to look at these examples and determine if the given function is periodic, and if so, state the period. The period being the horizontal length of one cycle. So remember, it's a repeated pattern of y values. So you're kind of observing the y values here. This is at 6, 6, so that repeats. You have one at 2, 2, 2, and then you have like 4, 4, 4, 4 here. So yes, it is a pattern of repeated y values. You can also tell that it's kind of periodic. It's kind of like a rhythmic machine that does your heart rate. If you've ever seen those like in the hospital, like beep, 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 you kind of have that periodic rhythm. So yes, this is periodic. And then what is the period? The horizontal length of one cycle. The cycle is when this starts repeating itself. So this is, if we start kind of like down, we go up and we go down again, or up, down, up again. So I'm going to go from basically crest to crest or peak to peak. If you ever learned about waves in science class, so like these two peaks would be one period because that is when the y repeats again. I'm hitting 6 and then I'm hitting 6 again over here. So this is your cycle or your period, and we're going to count 4 to 6 to 8, 10, and 12. How far is it from 4 to 12? So that is 8. It takes us 8 to get from 4 to 12. So our cycle here is 8. Our period is 8. All right, what about B? Is that periodic? So hopefully you notice that it is in fact repeating y's in a pattern. It's a funky pattern, but it is repeating the y's in a pattern. So I'm up here at 5, it looks like, and then I hit 5 again over here. So from here to here would also be your cycle. So yes, this is periodic. So let's count. We're at 3 and we come up to 7. How do we get from 3 to 7? We add 4. So our period or our cycle is 4. Now, this one is not periodic because from crest to crest, it's not repeating the y value. This is at 3. I'm sorry, this is at 1. This is at 2. This is at 3. So I'm not repeating y here. Okay, and it kind of looks like a staircase versus repetition. So this is not periodic. There's no period. Last one, again, kind of funky, but is it repeating a pattern? Yes, it is. So I'm going to go from these lower peaks. So you could go from low or you can go from up top, but you'd have to go from this one to this one. Okay, so I'm going to go low here, from here to here. So yes, it's periodic. And I'm going from 2, it looks like, to 5, and that it would be a period of 3. So that is how you tell if it's periodic and to state the period, because it is one cycle when that y repeats again. All right, so what does this look like for specifically sine, cosine, and tangent functions? We're going to make a table of domain values, we're going to graph the table, and then we're going to talk about some characteristics. Now this also still comes from our unit circle, so if you have your paper plate, you can take a look at your paper plate with the different values. I'm going to keep this really simple. It wants me to do a table from negative 2 pi to 2 pi. So starting at negative 2 pi up to 2 pi. I'm just going to count by half pi's. I could get into like pi over 4, pi over 3 and stuff, but that's it. It's just easiest if you do pi over 2s because easy numbers are kind of happening there. So if I'm kind of counting down from this 2 pi, I would be at 3 pi over 2, 1.5 pi, pi, pi over 2, 0, negative pi over 2, negative pi, and negative 3 pi over 2. So if you think about, or you have your unit circle, you're going to look at each of these values and talk about what the y value is, because remember, sine is talking about y, cosine is talking about x. What's the y value at each of these numbers? Okay, so at positive 2 pi, what's the y value? 0. At positive 3 pi over 2, what's the y value? Negative 1. At pi, what's the y value? 0. Pi over 2, what's the y value? 1. 0, what's the y value? 0. Now, negative pi over 2. Starting at 0, if I want to go negative half pi, I'd be coming down this way, because remember, we go clockwise to go negative. So if I go down this way to negative pi over 2, I'm actually at negative 1 here. Negative pi would actually put me back at pi, so we're still at 0. Negative 3 pi over 2, so negative half, whole, 1.5, or negative 3 pi over 2 would give me 1. And then negative 2 pi takes me back to the beginning at 0. And hopefully you see that this is periodic, 0, 1, 0, negative 1, 0, 1, 0, negative 1. It repeats the pattern. So we're going to go ahead and actually graph this on our little grid here. And the way that you're going to graph it is along the x-axis. Instead of whole numbers or integers, we're going to use these pi numbers. So I'm just going to count. I'm going to skip lines. So this is going to be my 0, obviously. Pi over 2. I'm just not going to write it because it gets a little difficult to see. So the second line here is pi, and then 3 pi over 2, and then 2 pi. And then same thing going down, negative half pi, negative 3.5 pi, or 3 halves pi, and then negative 2 pi. So I'm just going to write those so that it makes it a little bit easier. All right, then we're going to graph. At negative 2 pi, you're at 0, so I'm going to put a 0 dot. Negative 3.5, you're at 1, so you go up. Negative pi, 0, negative pi over 2, negative 1. 0 is at 0, pi over 2 is up at 1, pi is at 0, 3 pi over 2 is down at negative 1, and 2 pi is at 0. Then we're going to graph and just have a little extension at the ends because this is repeating. Okay, we're just graphing it from negative 2 pi to 2 pi. All right, so that is your basic sine graph, and there's some specific characteristics of sine that's different from cosine. So the domain here, because we're continuing left and right, is going to be negative infinity to infinity. The range, though, pay attention to what all the y's are that you're hitting. You're only hitting down to negative 1 and up to positive 1. So your range is negative 1 to positive 1 because you're not going any higher or lower than that. The period, when does this pattern repeat, right? When does this pattern repeat? So to get basically from crest to crest or low down here to low down here, it takes a period of 2 pi. Okay, 0 to 2 pi, if you kind of look at 0 to 2 pi, that's when it fully repeats again. 0, 1, 0, negative 1, 0, 1, 0, negative 1. So it takes 2 pi for the period. Amplitude, how tall is the graph? And that's kind of here and here. We only go up to 1, so this is your amplitude. So it's 1. And I'm going to just do a little highlight. This is your period because that's when the graph repeats again, and it would repeat again. All right, important part of the graph, when the domain is positive, so we're just kind of focusing on the right side of the graph, so from 0 over, when the domain is positive. If you start at 0, 0, you are going to go up, down, down, up. So what I mean by that, starting at 0, 0, up, down, up. And then that's going to repeat. So up, down, up. Start at 0, up, down, up. That can just help you, maybe they're asking you to identify if it's a sine or cosine graph, and you can't remember. So think about starting at 0, 0, up, down, up. Unless we shift the graph around, which we'll talk about on the back. All right, cosine, so still the same domain values. We're going to write those all in here. It's exactly the same x values as before. But what's going to change here, guys, is the y values, because now we're focused on the x's for the cosine. Starting at 0 or 2 pi, or remember this is also negative 2 pi, because when you come all the way around, depending on which way you go, what is the x value? It's 1. So at 2 pi, 0, and negative 2 pi, we're going to put 1. All right, let's go positives first. So 2 pi, and I go down to positive 3 pi over 2. I'm down here. What's my x value? It's 0. At pi, over here, what's my x value? It's negative 1. At pi over 2, what's my x value? It's 0. Now, negative. Starting at 0, if I want to go negative, I have to go this way. Remember, I went positive, counterclockwise, negative this way. So this is negative pi over 2, so we're looking at 0. Negative pi takes you all the way back to 180, so it's negative 1 again. And then negative 3 pi over 2 up top here is 0. So notice this is like completely changed, completely kind of reversed from the sine graph. So I'm going to put my pi and 2 pi on here as the same as I did. And then we're going to graph. At negative 2 pi, you're up at 1 this time. Negative 3 pi over 2, you're at 0. Negative pi, you're down at negative 1. Negative pi over 2, you're up at 0. 0, you are up at 1. Pi over 2, you're at 0. Pi, you're at negative 1. 3 pi over 2, you're at 0. 2 pi, you're 1. So then your graph kind of looks like this. It's kind of like a W shape. It's kind of how I compare it. This is like, I try to say like sine is your typical wave shape and like cosine is your W shape, if that helps you. Okay. What are the characteristics of the cosine function? So you still have the same domain and range because you're still going from all the way left and all the way right eventually, so negative pi to, or negative infinity to infinity. The range is still negative 1 to 1 because you're only going down in negative 1 and up to 1. The period is still 2 pi. The amplitude is still 1. Remember, this is your basic cosine and sine function. On the back, we're talking about all the changes that can happen, and all of this can get changed. So just keep that in mind. All right, again, when the domain is positive, so I'm focused on starting at 0, 0, and going to the right. So you're going to start at 0, 1, because at 0, your y is 1. You're going to go down, down, up, up. So it's a little different. This one was up, down, up. This one is down, up, up. Okay? Now, again, we're not going to be tested on tangent, but it is important to just see tangent, especially if you're going into higher math. This one is only negative pi to pi, and there's a reason why. So I'm going to go ahead and list all my halves here. All right, and remember for tangent, it's y over x. So you're taking the y value and putting it over the x value and then simplifying, okay? So if I have my plate starting, we'll just start at 0 because that's kind of easy. The y is 0, the x is 1. 0 divided by 1 is 0. Now let's go to pi over 2, so up here. The y is 1, the x is 0. 1 divided by 0 cannot happen, and therefore it's undefined. I should have done this in pink, sorry. Pi, we are at 0 divided by negative 1, so that's 0. Negative pi over 2, remember if we go to negative pi over 2, it's like going to 3 pi over 2, so we go this way, negative pi over 2. Again, negative 1 divided by 0 cannot happen, it's undefined. And negative pi is going to be the same as pi. So that's why this one's a little different. So in this case, you're going to have asymptotes. You're going to have asymptotes where this is undefined because you cannot cross that because there is no definition there. So I'm going to put negative pi and pi. And then this is going to be my negative pi over 2 that I'm going to draw an asymptote, and my pi over 2 that I'm going to draw an asymptote. So you can already see how the graph is a little different. All right, at negative pi, we're at 0, and what's going to happen is we're going to swoop just up to the right, approaching that asymptote. At 0, we are at 0. We're going to swoop still up to the right, but now we're going to also swoop down to the left. And at pi, we're going to just swoop down to the left. Now, essentially, this would, like, you'd have more of your graph here, and you would still swoop up. And you'd have more of your graph over here, and you would still swoop down. But just for the picture, this is kind of what you get. But there is still some swooping down here happening, and some swooping up here happening. This is going to keep repeating. Okay? All right, the domain therefore gets changed because instead of being all real values, we're all real values except at these halves. And it continues, guys. The pattern keeps going. There is still an asymptote here and here if I were to keep this graph going. So it's actually negative infinity to infinity, except x cannot equal multiples of pi over 2. So what I mean by that is any pi over 2's, any negative pi over 2's, and then 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. Because it's going to keep repeating. The range this time is negative infinity to infinity because we keep going all the way up and all the way down for y. Your period, when does this happen and repeat? It's on intervals of pi instead of 2 pi. And you have asymptotes. You don't have amplitudes because we keep going forever. Your asymptotes are when x equals any pi 2 multiples, and we say plus n pi. So again, if I have half a pi and I add 1 pi to it, I'm going to have 3 halves pi. If I add 2 pi to it, 5 halves pi, etc. All right, important parts of your graph here. You have asymptotes at 1/2 pi's. You have dots at whole pi's. And that's what I'm talking about here, the zeros. Okay? And it is a cubic shaped graph. So what I mean by that is like x to the 3rd power takes also on this shape. All right, so those are the basic functions, basic graphs of sine, cosine, tangent. Now we know that we should be seeing the patterns now, that there's always stuff that gets added and multiplied to these graphs, which makes them change, shifts them around, multiplies them out, etc. So we're going to look at that. Okay. So I want to start first by the basic. The basic is sine or cosine or tangent, but we're just going to focus on sine or cosine of x. Sine of x, cosine of x. So look at how this has changed down here. We've added on an a b on the x, a plus minus c, and a plus minus d. And remember, all of those things cause a shift or something to happen and affect the graph. They're called parameters. The parameter or letter affects the graph differently. So we're going to talk about what they do. So parameter A, the one in the very front of the whole thing, it would be in front of the sine or cosine here. A represents the amplitude, which describes how high or low the graph will be. Parameter B represents the period and describes where the cycle repeats. So remember, you're going to still need the original. Sine and cosine, it's 2 pi. And tangent, it's pi. Oops, sorry. Sine and cosine, it's 2 pi. Tangent, it's pi. A period change occurs when there is a coefficient on x, a number in front of x. So coefficient on x, that b there basically is what I'm talking about, if there's a number on x. And we determine the period change by taking the normal period, so that 2 pi for sine and cosine, or the pi for tangent, and we divide it by that b. If it's just 1, then your period doesn't change. But if it's 2 or a half or a different number, it will change. So if it's 1, it's not going to change. It's going to be 2 pi divided by 1. But if it's 2, 2 pi divided by 2 makes you have a period instead of pi. All right, parameter C, so you see a plus minus C there, is the phase shift and describes if the graph is going left or right. And that's same as before, guys, that we've seen. If it's in there with the x, it's going left or right. Now, this is a little tricky, but if we do negative c divided by b from up here, and it's less than 0, so it's a negative, we're going to go left. But if we do negative c divided by b and it's greater than 0, we're going to go right. And I'll explain that in the examples down below. And then we have d, which is your vertical shift. And again, that's kind of the same from all of the functions we've been seeing because it's outside of everything. And that describes if the graph goes up or down. So you have seen this happen in all the other functions we've been talking about all year, absolute value, log functions, etc. But we just have a sine, cosine, tangent. So it's just a wavy looking graph. Okay. We're going to skip C. If you want to do it, you can, and I can give you the answers and go through it, but we're going to really focus on the sine and cosine ones, okay? So what I like to do is I like to go through and kind of label where A, B, C, and D are. A is right here with the 3. I'm on letter A. B is on the X, which happens to be a 1 because there's nothing there. C would be inside the parentheses, adding or subtracting, but there is no C, so C equals 0. And then this is D. So if you did that for B, this would be A. B again would be 1, C, D. I think it's just helpful. So the amplitude, A, the number in front of everything, that's 3. Super easy for that. The period, so normal sine period is 2 pi, and I have to divide that by B, which is 1, so your period just stays the same at 2 pi. Phase shift would be none because we don't have a C. C is 0. And then vertical shift is up 1. And that's it. Pretty simple, pretty straightforward if you follow kind of the directions. Now let's talk about B, and then I'm going to tell you to pause the video and do D and E. So B, amplitude's 2, period, 2 pi divided by 1 because that's B, so it's still just 2 pi. Phase shift, so remember, phase shift is parameter C. You need to take negative C, negative whatever C is, and divide it by B. So I'm going to take negative pi over 2 and divide it by B, which is 1. Which anything divided by 1 is just itself. So this ends up giving me a negative pi over 2. If negative is less than 0, that means we are moving left by pi over 2. So we're moving left pi over 2 because it's a negative. And then we have a minus 4 for D, so we're going down 4. So go ahead and pause the video, try D and E, and then come back to the video and check your answers. Hopefully you pause the video. So again, labeling is helpful. There's a 1, an invisible 1 here if there's nothing there, so that's A, B, C, D. So your amplitude is 1, A is 1. Your period, 2 pi divided by half, or keep change flip, 2 pi times 2, essentially, becomes 4 pi. The period is 4 pi. Phase shift, you take C and make it negative, negative 3 pi, negative C, so negative 3 pi, divided by your period, which is not your period, your B, which is a half, which gets me negative 6 pi, which means I'm going left by 6 pi, left 6 pi. And then we have a plus 5, so we're going up 5. And for E, this is A, B, C, and D. 5 is the amplitude. 2 pi divided by 4 for the period would be pi over 2, because 4 is your B. Now, you have a negative already, so when you do negative pi over 3, that's what changes us to a positive. So if you're like, how am I ever going to go right, Miss Wallace? Negative will change you to a positive, divided by B, which is 4. So this makes us have positive pi over 12. So this means we are going right pi over 12. And if you're not sure how to do that, I can walk you through it. And then we are going down 6 because it is minus 6. All right, so that is just figuring out amplitude, period, phase shift, and vertical shift from the function. You can graph these in Desmos, but are you going to be able to see and tell the amplitude, period, phase shift, and vertical shift of each function? Maybe if you plug the original in, just sine of x or cosine of x, and then you plug one of these new ones in, you might be able to tell like what the amplitude, period, phase shift, or vertical shift changes. But it is helpful, more helpful and quicker if you know how to get each of them. So now we're going to take all of this knowledge, still the same knowledge down here, but we're going to actually be graphing. So we're going to, again, cross through B because it's a tangent, but you can do it if you want. All right, so first thing that's helpful to do is label. So A, B, C, D. And just list all your stuff. So amplitude is 4. That means we're going to go a height of 4. So normal height is 1. We're going to stretch it to a 4. Period. So 2 pi is normal divided by B, which is 1. So we're sticking with 2 pi. So when does it repeat? Now, if this is smaller, then that means our graph is going, let me get a piece of paper. If this is, okay, so like, let's say this is normal. If we have, and this is 2 pi, repetition. If you have a repetition of pi, you're going to get shorter because it's going to repeat quicker. And if you have a repetition of like 3 pi, then you're going to get more spread out and longer. Okay, so that's what the period changes do. Just wanted to kind of explain that. All right, phase shift. So we take negative c, so negative pi over 2 divided by b, which is 1, so negative pi over 2. So that means we're moving left basically a half, or 1 space. And then vertical shift minus 2, we're going down 2. Okay, so how do we graph this? What I like to do is graph the original points, the original sign points. You can get them from the front of your notes if you would like. So again, I'm just going to stretch out. I'm going to do negative pi. This would be my negative pi over 2. I just want to write it in. Pi over 2, pi, 3 pi over 2, 2 pi. And then graph your original points. For sine, if you are at 0, you're at 0 for y. If you're at pi over 2, you're up at 1. If you're at pi, you're at 0. Down 1, 0. And then etc. You can keep going. So that just kind of helps. This is the original. Now, I have to stretch it to 4 amplitude. I have to phase shift half left. So just one, everything's going to move 1 space left. And then I have to vertical shift down 2. So for the vertical shift, you can picture that the 0 line is kind of coming down 2. So if you want to dash that in, that's our new x-axis essentially. Okay. All right, so what I'm going to do right now is I'm going to get a pencil and I'm going to kind of draw in these dots one at a time for you and erase as we go, so you can see where the final image ends up. So amplitude, this is at 0, which means my amplitude means times 4. 0 times 4 is 0, so that's not going to, the amplitude is not going to change this dot. Phase shift half a pi left, so you're going to go left basically 1, and then vertical shift down 2. So amplitude didn't do anything. Here's my phase shift, and then I have to go down 2. So this is the final point where that dot ends up. So I'm right here. I'm going to do pink when it's final. And then I'm going to kind of erase the other little dot. Oops. So this one's up at 1 times 4 would give me 4. So 1, 2, 3, 4 would be my amplitude. Phase shift half left, so go over to the left half. And then down 2, 1, 2. So that's your final spot with the dot. And if you notice, it should be 4, since it's an amplitude, away from this line, because this is our new line. 1, 2, 3, 4 it is. You can erase the other dots. All right, this point, 4 times 0 is 0. Over half, over 1, down 2, right here. This dot times 4 is negative 4, so it would be down here. Over half, up to, well, no, I'm confusing myself, sorry. Hold on. Sorry, so negative 1 times 4 would be 4, or negative 4, so 1, 2, well, hold on, negative 1, negative 2, negative 3, negative 4. And then, yeah, so negative 4. And then over left 1, and then down 2. Yeah, so I was just confusing myself. And then 0 times 4 is 0. Over a half, down 2, put you on that line. And so this is your graph. Now, again, it would extend and keep going left and right, but we're just doing this a little bit, okay? For a period, this would be over a period of 2 pi. All right, I know it's really tricky to graph. Okay, so we're skipping down to C. This is cosine, so again, it starts out a little different. A, B, C, D. So amplitude is 3. Period, 2 pi divided by B, which is 1, gives us 2 pi. Phase shift is negative pi divided by 1, because we always do negative C. So negative pi, which gives us pi, so that means we're going right pi, or basically 2 spots, because we're counting by halves. Depends on how you count by. I'm counting by halves here, so we're going to move 2 spots. This one up top, we moved 1 spot because we were counting by halves. And then vertical shift, I'm going up 1. So again, I'm just going to go ahead and draw in my vertical shift of up 1. I'm going to draw in my original points, just a couple of them. So at 0, you're up at 1. At 1, you're at 0. Or half pi. Let me do that first. So we have negative pi, 2 pi. So at 0, you're up at 1. Pi over 2, you're at 0. Pi, you're down at negative 1. 3 pi over 2, you're at 0. 2 pi, you're at 1. That's just over a period of 2 pi. So we have this kind of V shape going on. So now let's do all of our shifts. So this is 1 times 3 would be 3. 1, 2, 3. Phase shift to the right 2. Boom, boom. And up 1. One thing I'm going to do, sorry, I forgot to do. I'm going to make this a 1, and I'm going to show 2, 3, 4. Okay, sorry. We're at 1 times 3, just times 3. Don't move 3 up, because that's what we're doing with the vertical shift. But times 3 will put me at 3. Okay, and then phase shift right 2 spaces, and then up 1 puts you up here. Okay, 0 times the amplitude is 0. Phase shift 2 to the right, 1, 2, up 1. Negative 1 times 3 will put us at negative 3. And then shift negative 1, negative 2, negative 3. Shift 2 to the right. And then up 1. And then last point, oh wait, no, this point, 0 times 3 is 0. Over 2, up 1. And then this point, multiply by 3, over 2, up 1. And you end up with this kind of shape. And this one could have kept going up here too. All right, D. So this is A, B, C, D. Amp is 2. Period is 2 pi divided by a 4th, which ends up giving us 8 pi. Just do 2 divided by a 4th, you get 8. Phase shift, negative 3 pi over 2, which means we're going to have a positive, divided by a 4th, gives us 6 pi. So you're going to go right 6 pi. And vertical shift, you're going to go up 4, because plus 4. So I'm going to make this graph a little different because we have such a wide period and phase shift. If you count by halves, it's going to be not enough spacing. So instead, I'm going to choose to count by 2 pi. So this is 2 pi. I'm going to call this 4 pi, 6 pi. I'm going to call this 8 pi, just to kind of help us out. And then what I'm going to do is I'm going to graph the points from the original sign in terms of 2 pi. So at 0, we're at 0. At 2 pi, we're at 1. At 4 pi, we're at 0. At 6 pi, we would be down at negative 1. And at 8 pi, we're up at 0. So you get that little sine wave. You could probably maybe have done pi, but then pi, 2 pi, 3, 4, 5, 6, 7, 8. You could have done by pi and gotten out to 8. It would just be a little bit wider than my picture. All right, so here's all of our shifting. Amplitude is 2. Oh, wait, sorry. Shift up 4. So let's do that first with our line. 1, 2, 3, 4. So that's helpful because at your zeros, you should just be hitting this line, but you are shifting to the right as well, so we gotta just be careful. All right, so amplitude is 2, so 0 times 2 is 0. Phase shift is 6. By period, I've already driven in, or drawn in. My phase shift is 6 pi. Now, since I'm counting by 4, that really means I'm just gonna move 3 to the right. So 1, 2, 3, and then I'm gonna go up 4. 1, 2, 3, 4. So next one, 1 times 2 is 2, so I'm up here. 3 to the right, 1, 2, 3, up, 4. 1, 2, 3, 4. Let me make sure I did that right. Hold on. Okay, I'm just going to count by 2, 3. Okay. 0 times 2 is 0, and then phase shift 3 to the right, 1, 2, 3, up, 4, 1, 2, 3, 4. This one's down at -1, so amplitude of 2 is -2. Over 3 to the right, 1, 2, 3, and then up 4, 1, 2, 3, 4. Yeah, essentially want to be down here. So I don't really know what happened with that one. Oh, I'd wanted times. And then go 1, 2, 3, 1, 2, 3, 4. Wait, no, I didn't do that right. It was here. Oh, sorry, guys. This one's not right. I'm gonna ignore that little dot. It was like, yeah. And then your last dot would be times, yeah, so, sorry, times 2 over 3 up 4. I was getting myself confused. And then this one times 3 is 0 over, I'm sorry, times 2 over 3 up 4. So you end up with this. And your amplitude in here should be 2. That's kind of how you could check yourself. All right, I know that's difficult. Again, EOC is more looking for what's the amplitude, what's the period, what's the phase shift, what's the vertical shift. Maybe they give you the question and they say match the graph, or the graph and match the equation, which you have Desmos available to you to help you. But knowing how A, B, C, and D will shift the graph around is important. And the last lesson that we're going to do is 7.5, which is about trigonometric equations and modeling.